Friday! I actually realized when I was drawing this out that it's not actually Friday for you guys, it's actually Thursday for you guys, and I've been saying the wrong days in all of the videos. But if your days are anything like my days, I actually forget what day of the week it is because everything just kind of blends together at this point. So happy whatever day it is. Hopefully you've had a good week, had a good start on your homework this week already and getting things done. So today's lesson is actually one of the harder lessons in the unit. I don't say that to scare you, but there are going to be steps and there are going to be notes. So I would grab a scratch piece of paper and kind of take some notes, and we'll take some step-by-step notes after we do a problem together so that you have a way to organize each step. So with that being said, I do want to review something before I get started on the lesson. We are going to be working with slope-intercept form. And if you remember slope-intercept form, that was the y equals mx plus b, where m is the slope. And if you remember anything about slope, hopefully you remember it means rise over run. It talks about a constant rate of change. And when we also had a formula, and we used this formula in that water park project, and it was y2 minus y1 over x2 minus x1. So hopefully those are all things that describe slope, which is the m in our slope-intercept form. The other thing that is important to mention is the b, and our b represents our y-intercepts. And hopefully you remember that the y-intercept means where it crosses the y-axis, which hopefully you remember also is your vertical axis. So those are some just quick vocab review. So let's actually get into our books. And we're going to be in our book on page 680. Most of your assignment, I shouldn't say most, half of your assignment you're going to get done with me. So as long as you're writing in what I do and copying down all the work, you're going to get half of your assignment done. Just make sure you write everything down so I can give you full credit for it. So the first thing we're going to do is, we've been doing scatter plots. We're good with that. We've been working on lines of best fit. Now we're actually going to write an equation in slope-intercept form for that line of best fit. So you can see they already graphed it for you. They have that line of best fit. The first thing that we're going to do is we have to figure out the slope, and we have to figure out the y-intercept. So let's do our slope first. When you are calculating your slope, or m, you're going to need to pick 2 points. And it has to be 2 points that are on the line. It does not have to be 2 actual data points. So I'm going to pick that one because it's easy to determine the x and the y. I know its x is exactly 1 and its y is exactly 60. I don't have to guess. I'm also going to pick this point right here because I know that exact point. Now I know that's not a data point, but it is a point on the line, and since we're trying to find the equation for the line, we can use it. So any point that falls on the line can be used for this. So that point is x is 4, comma 65. So to find my slope, I'm going to use those 2 points and the formula y2 minus y1 over x2 minus x1. Hopefully you remember that this would be x1, this would be y1, this would be x2, and that would be y2. So now I'm just going to plug it into my formula. Y2 is 65 minus y1 is 60 over x2 is 4 minus x1 is 1. So now I would just calculate 65 minus 60 is 5 over 4 minus 1 is 3. So I found my slope, or m, to be 5/3. Okay, so now we have to figure out that y-intercept. So to figure out that y-intercept, we're actually going to use one of those points that I just did for slope. Hopefully you remember this too from your water park project. So I'm going to just pick this point. It doesn't matter if you pick the top point or the bottom point, but you're going to pick one point, and you're going to substitute its y value in for y, and you're going to substitute its x value in for x, and then we're going to solve for b. So what that looks like is my y in this point is 60. So 60 equals m we found to be 5/3. My x in this point is 1. So 5/3 times 1 plus, we don't know what b is, so I'm going to leave it as plus b. So now I'm going to try to solve for b. I have to simplify that left-hand side first, so it actually takes 5/3 times 1, which is 5/3, plus b equals 60. And then to get b all by itself, since 5/3 is added to b, I'm going to do the opposite, which is subtract it. You can type it in a calculator. 60 minus 5/3 gives you 58 and 1/3. So that is my b. So now that I found the b and I found the slope, I can just fill in the rest for my equation in slope-intercept form. Y equals 5/3 x plus 58 and 1/3. So that is your answer for C. We're not going to worry about interpreting right now. All right, for part D, we're going to use the equation to make a conjecture about the graduation rate in 2020. So if I look at my x-axis, it actually labels it as 1998 is year 0. So then 1999 would be 1. 2000 would be year 3. So therefore, 2000, oops, I said that wrong, I'm sorry. Let me backtrack. Year 1998 is 0. So year 1999 is 1. Year 2000 is 2. So then 2020 would be x equals 22. So to figure out where x is 22, what is the value of y? We replace x with 22 in our equation that we just wrote. So y equals 5/3 times 22 plus 58 and 1/3. Now I just do my order of PEMDAS since everything is on the same side of the equation. I would type in my calculator 5/3 times 22, and I get 36 and 2/3 plus 58 and 1/3 and I get 95. So y equals 95. All right, since this video is actually already 9 minutes, I'm going to make a new video, and I'm going to do your entire homework assignment on that new video, so make sure you watch both.